Okay, in this video, we're going to solve a couple problems related to laws, sines, and cosines. The first problem says, a reconnaissance airplane P flying at 10,000 feet above a point R. So I have my plane here. It's flying above point R. On the surface of the water, spots a submarine S. So we have a submarine here, S, at an angle of depression of 37, and it's marking the angle of depression. And a tanker T, here we see it at an angle of depression of 21 degrees, as shown in the figure. In addition, angle SPT, so this big angle right here that is being marked with the arrow, it's 100, and it found to be 110 degrees. Approximate the distance between the submarine and the tanker. So we're looking for this. In this case, we're looking for R. So even though we have information here, like in the sky, we have this triangle here, SRT, that is going to help us to find this distance R. The first thing that we know is that this 110 degrees on top, let me try to like close it here. This is like, it's actually a prism. So in this prism, as this angle is 110 degrees, then it's going to be exactly the same on the bottom. So this angle right here, it's 110 degrees. Okay. Now we have the angle. Now that we have the angle, we know that since we cannot guarantee that this triangle on the bottom is a right triangle, we need information to help us get this distance R. The first thing that we remember that is that the problem tells us that this angle of depression is 21 degrees. So this here is going to be 21 degrees too, right? 21 degrees. Also that if this is 37 degrees, then this will be 37 degrees. Now with this information, can I get more data for the bottom triangle? Notice that it says that the airplane is flying at 10,000 feet. So this distance here, this height is 10,000 feet, right? Now we have two different triangles with a lot of information. We have the first triangle, this one, okay, that it says that we have a right triangle, 10,000 feet here, and we have 21 degrees, right? Notice that if we use trigonometric ratios, we can find this side and this side, actually, all right? And finding y is not helping me at all, but finding x, it means I will get this length. So I can find that length right there. And if I can do this analysis, the same goes with the other triangle. So if I have this triangle here, right, this is 10,000 feet. I'm analyzing this one now. 10,000 feet. This is 37 degrees, right? I can find this side or this side. But again, this side is not helping me at all. So I'm just going to find M. So I can find this side here. Now, all right, that's information that I can extract from the data. Now, if I look for these two values, it's going to help me with something. And yes, because notice that if you have the value for M and for X, then you have side, angle, side. And if you had side, angle, side, you can use my law of cosines, right? And with law of cosines, remember that we have a formula that we can use to find the sides. So let's do that. So for this triangle, remember that we're not going to find y, we're going to find just x. Since we have opposite side of 21 and the adjacent side, then tangent of 21 degrees, because tangent is the only one that will relate opposite and adjacent, is going to be equal to 10,000 over x. So x is going to end up being equal to 10,000 over tangent of 21. But how much is tangent of 21? All right, let's get the calculator. We calculate with the calculator tangent of 21 degrees, and it's 0.383. So let's use the 3 first decimals. So x is going to be equal to 10,000 over 0.383. So now we just need to divide that. All right, so 10,000 divided by 0.383 will be 26,000. So approximately 26,000 on 9.66. All right, so that's our value for x. So let me close this real quick. For m, So basically with the same idea, right? Tangent of 37 degrees is going to be opposite to 10,000 over m. If we isolate m, we get that m is equal to 10,000 over tangent of 37 degrees. Tangent of 37 degrees, let's see. Tangent of 37 degrees is 0.753. So we're going to divide 10,000 by 0.753. That is, this is m is equal to 13,280.21. All right. 21 too, my bad. And I missed one decimal here, so let's do it again. 10,000 divided by 0.383. 0.383. All right. 660. We didn't. All right. I just forgot that it was a 0. Okay. Now that we have this piece of information. Now we can find, or we can use, law of cosines, right? So the law of cosines tell me that this side r squared, is going to be equal to the addition of the other two squared. So 13,280.212 squared plus this square, the other side square, so 26,109.66 square, minus 2 times these two numbers. All right, 2 times these two numbers. It's a little bit cramped up, but you get the idea. 0.66 times cosine of the opposite angle. So cosine of 110 degrees. Okay, so let's put all this in the calculator. We get that 13,280.212 square plus 26,109.66 square. Well, actually, all right, let's do it all. Since we don't have too many space, 2 times 13,280.212 times 26,109.66 times cosine of 110 degrees. So this is our result. Let's just copy it. 95,263,750.06. All right. And we need to square this, right? But because we need to isolate r. So the square root of that, of 95,263,750.06 is going to be 33,094.679. So basically we can approximate this to 5, right? So approximately 33,000 feet, I think. Yes, feet. All right. So this is how you solve this type of problem. Okay, it's not hard, but in this case we have a lot of big numbers to deal with, and you need to be really careful how to use them. All right, so let's see another problem. We have this that says a commercial fishing boat uses sonar equipment to detect the school of fish 2 miles east of the boat and traveling in the direction of north 51 degrees west at a rate of 8 miles per hour. If the boat travels at 20 miles per hour, approximate to the nearest tenth the direction, and should head to intercept the school of fish. So basically they're asking me for this, right? If we have our cardinal points here, they're asking me for this angle, right? Because that will be the direction. Now let's read it again. The fishing boats use sonar to detect the school of fish 2 miles east. So we're good here. We have the boat here, east is here, so we have the school of fish here. And traveling in the direction of, okay, so the fish is traveling northwest at 51 degrees at a rate of 8 miles per hour. So if it's if this is the rate, then we know that in 1 hour they will cover 8 miles. So we know that this is 8 miles, right? If the boat travels at 20 miles per hour, but in 1 hour, the boat will cover this distance. So since the boat is traveling in this direction, then it will cover 20 miles in this direction. Let me use a more brighter color. Yes, we're at 20. All right, 20 miles. Okay, so we have 20 miles, 8 miles, 2 miles, and we have an angle, if you notice. Because if this is 51 and we form a right angle here, then 90 degrees minus 51 will be 51 degrees will be 39 degrees, right? So this is 39 degrees. All right, let me complete the triangle here so you can see it better. All right, so the thing that we're looking for is this angle here outside, right? This. But we can find this angle, right? If we find this angle, we know that this, the whole thing, because of the cardinal points, are going to form a 90-degree angle. So with this, we can find this one, right? Let's put names to this. So let's call this A, let's call this B, let's call this C. So we have lower C, right? We have lower A, we have lower B, right? That is 20, and we have angle B. So we can relate these two values with sine of B, angle B over B, equal to the one that we're looking for. Like we're looking for angle A, we can relate it or write the ratio in between that angle and the opposite side. So sine A over A. Okay, so obviously sine of B, so B is 39, so sine of 39 degrees over B that we're looking over B that is 20, my bad, B that is 20 is going to be equal to sine of A is the one that we're looking for, over A that is 8 miles. So we isolate this and we get that sine of A is going to be equal to 8 over 20 multiplied by that sine of 39, right? Let's calculate this. 8 over 20 is 0.4, right? So 0.4. Sine of 39 is 0.629. If we multiply 0.4 times 0.629, we have 0.2516. So we know that sine of A is equal to this. Now, are we done? No, not really. We just need, let me do it here on top, to isolate A to get the value for the angle. So angle A is going to be equal to inverse sine of 0.2516. And the inverse sine of, or sine inverse or arc sine of 0.2516 is 14.57. 14.57. That if we want, we can approximate this to 15. So it's going to be 15 degrees. Okay, 15 degrees. Now, 15 degrees is this, right? 15 degrees. So since the whole angle in between the cardinal points, it's 90 degrees. 90 degrees minus 15 is going to be 75. So the direction is going to be 75 degrees. Now, since it's going northeast, then it's going to be north 75 degrees east. This is our direction, or the direction of the boat. Okay, so hope this video helps to understand these two problems that seems hard, but they are not so much if you read the problem properly and you know